Here is a gentler question than it first appears. What would happen if the sun went out not forever, but for a single day? Just one day. 24 hours of darkness, and then it comes back on, exactly as it was, and shines again as though nothing had happened. It sounds like it should be catastrophic, and there is a version of this that people imagine where the world freezes and everything dies in a matter of hours. But that is not what would happen, and the truth is far more interesting, and in the end rather reassuring. Because the Earth is a large, warm, slow object, wrapped in air and water, and a single day is not very long to something like that. A day without the sun would be strange and cold and frightening if you did not understand it, but the planet itself would barely flinch. Tonight, we are going to live through that day, hour by hour, and find out exactly what would change and what would not. And I promise, as always, to end by explaining why it cannot really happen, and to leave you warm and safe exactly where you are. But before we go a step further, let me ask you something softly, because it matters more than you might think. If these quiet journeys through the strange corners of our universe help you set down the weight of your day and find your way toward rest, then please take just a moment right now before you settle any deeper into the warm and subscribe. It is one small tap, but it means the next of these will find its way back to you on some future restless night when sleep is a long way off and you need somewhere gentle to put your mind. And it helps more than you could possibly know to keep these stories being made for you and for everybody else out there in the dark tonight looking for a little peace. So if you would, subscribe and stay with me night after night as we wander together through the great slow mysteries of the universe. And tell me, if you will, from wherever you happen to be resting tonight, in whatever quiet corner of the world is holding you, where are you listening from, and what hour has it reached where you are? Leave it in the comments below. It is a lovely thing to see all the places and all the hours gathered there together, all of us drifting off beneath the same turning sky, in 100 different countries and 100 different hours, all of us here in the dark at once. And now let your shoulders come down and let your breathing slow, and let the whole weight of your day loosen and fall away. Come with me through a single day without a sun, and let us see gently exactly what it would and would not do. Let us begin with the difference between this and the darker question, because it changes everything. If the sun went out permanently, the story is one of a slow, deepening cold that eventually freezes the whole surface of the world over years and centuries. That is a different scenario, and it is truly the end of the surface world, if a very slow one. But a single day is a completely different matter, and the reason comes down to a single idea, which is worth holding on to for the whole of tonight. The Earth is enormous, and warmth leaves it slowly. And that difference between a permanent loss and a loss of a single day is really a difference of scale. And scale is the whole secret of tonight. A great many things that would be catastrophic if they lasted are perfectly survivable if they are brief, simply because large, warm, slow things take a long time to change. A pond can freeze in a night. A deep lake takes all winter. The ocean, in most places, never freezes at all. The bigger and warmer the thing, the longer it can go without its heat source before it is in any real trouble. The Earth is the biggest and warmest thing you have any experience of, by an almost incomprehensible margin. And so the question of a single day without the sun is not really a question about catastrophe at all. It is a question about how slowly a very large warm thing cools, and the answer is slowly enough that one day barely matters. Think about how a large stone building holds its temperature. On a hot day, the inside of an old stone church stays cool for hours. On a cold night, a house that has been warm all day stays warm for a long time after the heating goes off. The bigger and more massive a thing is, the slower its temperature changes, because there is so much material to warm up or cool down. You know this from cooking too. A small amount of water in a shallow pan cools in a minute. A large pot of soup stays hot for an hour. A cup of tea goes cold on the table, while a full kettle beside it is still warm long after. Size is the whole difference. The more of a thing there is, the more slowly it gives up its warmth, because heat has to leave from the surface, and a big object has a great deal of inside for every bit of surface. The Earth is the largest and most massive thing in your experience by an unimaginable margin. It has oceans that hold a staggering quantity of heat, and an atmosphere and warm ground, and all of that stored warmth cannot drain away quickly. A day is simply not long enough. The planet would lose only a small fraction of its heat in 24 hours, and the deep reserves in the oceans and the ground would hardly be touched at all. And there is a second reason the cooling would be slow, which is worth knowing. Heat leaves the Earth by radiating away into space, and the rate at which anything radiates heat depends very strongly on how hot it is. A very hot object sheds heat fast. A merely warm object, like the Earth, sheds it slowly. So as the surface cooled a little, it would radiate even more slowly, and the cooling would gently slow itself down further. The world does not simply keep dropping at a steady rate. It resists more and more the colder it gets. So let us walk through the day, and you will see that the real story is not about the planet freezing, which it would not, but about the loss of the thing the sun does every second that we never think about, which is not so much heating us as simply lighting our way and driving our weather. Let us begin at the moment it happens. Say the sun goes out at noon, over the part of the world having its midday. For 8 minutes and 20 seconds, nothing changes at all, because that is how long the last of the sunlight takes to cross the gap and arrive. So for those 8 minutes, the sky is bright and the day is ordinary, and the sun that has already gone out still hangs there shining from the recent past. And then the light arrives that was emitted just after the sun went dark, which is to say, no light. And the sun goes out. It would not fade. It would simply switch off between one moment and the next, because the sun does not dim gradually. It is either sending light or it is not, and the last of the old light would arrive, and then there would be nothing behind it. For the half of the world in daytime, the effect would be staggering. Midday would turn to deep night in an instant. Not dusk, not gradual, but a sudden fall into darkness as complete as the middle of the night. The sky would go black, and the stars would come out, all of them at once at noon. And that alone, before anything else, would be one of the most beautiful and terrifying things anyone had ever seen. The full field of stars, the whole glittering sky, appearing in an instant over a landscape that a moment before had been in broad daylight, with the shadows vanishing and the world going dark all at once. And it would reveal a sky that almost nobody alive has ever properly seen, because our skies, especially over towns and cities, are washed out by our own lights, and the true depth of the stars is hidden from most people their whole lives. But in that sudden noon darkness, before anyone thought to switch on a single electric light, the sky would blaze with more stars than most people have ever witnessed. The full band of the Milky Way arching overhead. Thousands upon thousands of stars in a sky as dark as the deepest wilderness. It would be, for one strange and frightening moment, the most spectacular view of the universe that most human beings had ever had, hanging over a world that did not understand what was happening to it. For the half of the world already in night, almost nothing would seem to change at first. It was already dark. The stars were already out. The only difference would be subtle, and it would take a little while to notice. The moon would go out, because the moon makes no light of its own. Every scrap of moonlight is sunlight, bounced off the moon's grey surface toward us. So the instant the sun went dark, the moon would darken too, fading from the sky over the couple of seconds it takes light to cross from the moon to the earth. Anyone watching a bright full moon would see it simply vanish, and that, for the night side of the world, would be the first sign that something was deeply wrong. And every planet in the sky would go dark in the same way for the same reason, though it would take longer, minutes to hours depending on how far each one was, as the last sunlight they had reflected finished its journey to us. One by one, the bright wandering points of the planets would blink out, from the nearest to the most distant, over the course of the following hours. So within a few minutes, wherever you were on Earth, you would know. Half the world would have been plunged from noon into a starry midnight. The other half would have watched the moon and the planets go dark, and everywhere the same black sky, full of stars, and no sun, and no moon. Now let us talk about the cold, because this is where the reassurance begins, and it is greater than most people expect. The temperature would begin to fall immediately, but slowly, and crucially, it would fall at very different rates in different places, and understanding why tells you a great deal about how the world actually keeps itself warm. The land would cool fastest. Ground, especially dry ground, does not hold heat very deeply. It warms up quickly in the day and cools quickly at night, which is something you already know if you have ever felt how fast the desert cools after sunset. So over the land, and especially over dry inland regions and deserts, the temperature would drop noticeably within hours. But here is the thing. We already have a natural experiment for this every single day, and it tells us roughly what to expect. It is called night. Every night, your part of the world loses the sun for many hours, and the temperature falls, and then the sun comes back and it warms up again. A day without a sun would begin, for the daytime half of the world, rather like an unusually long and early night. The temperature would fall the way it falls on any clear night, which is to say meaningfully but not catastrophically. And in fact, we have a natural experiment for something even closer to a sunless day at the far north and far south of the world. In the polar regions, in the depth of winter, the sun does not rise at all, sometimes for weeks or months on end. There are places where people live through a night that lasts not 12 hours but 60 days, or 90. And it gets very cold in those long polar nights, colder than most of us have ever felt. But it does not run away to some unthinkable extreme. It settles. The land cools and then reaches a kind of balance and stops falling, held up by the warmth still leaking from the ground and the ocean and moved around by the air. People live there. They always have. A single dark day over the temperate and tropical world where most people live would be milder by far than an ordinary winter's night inside the Arctic Circle, which happens every year and which nobody considers the end of the world. In most places, a clear night sees the temperature drop by something in the region of 10 degrees between sunset and dawn. A day without the sun would extend that, pushing the cooling further than a normal night does, so that by the end of the 24 hours, the daytime half of the world would be colder than it has ever been at dawn. Uncomfortable, dangerous in already cold places, but over most of the temperate and tropical world, in the space of a single day, not fatal to a person who is dressed for winter and indoors, and the oceans would barely change at all. This is the great stabilizer, and it is worth dwelling on. The oceans hold an almost incomprehensible amount of heat. Water is extraordinarily good at storing warmth, far better than rock or air, and there is an enormous quantity of it, kilometers deep, covering most of the planet. All of that water is currently warm, and it would stay warm. In a single day, the oceans would lose an utterly negligible fraction of their heat. The sea surface temperature would hardly move. It is worth understanding just how much heat is in the oceans, because it is the single fact that most protects the world in this scenario. The oceans cover about 7/10 of the planet, and they are on average several kilometers deep. The total amount of warmth stored in all that water is so vast that it dwarfs everything else. The entire atmosphere, all the air of the whole world, holds only a tiny fraction of the heat, held in just the top few meters of the ocean. The sea is where nearly all of the planet's accessible warmth is kept, and that heat moves slowly and reluctantly. Water gives up its warmth grudgingly, which is exactly why the sea is so much milder than the land, why coastal places have gentler weather than inland ones, why an island in the middle of an ocean barely knows the difference between summer and winter. The ocean is the great flywheel of the Earth's temperature, smoothing out every change, resisting every swing, and it would resist this one too. A single day of darkness would take from it an amount of heat so small as to be almost unmeasurable. And because the oceans stay warm, and because air moves, the coasts and the islands and everywhere near the sea would stay far milder than the deep interiors of the continents. The ocean would go on quietly breathing its warmth into the air above it, all day and all night, sun or no sun. So the picture, after a full day of darkness, is not a frozen world. It is a world that has had one very long, very cold night. The deserts and the dry interiors of continents would be brutally cold, colder than their coldest winter nights. The coasts would be chilly, but survivable. The oceans would be essentially unchanged. And the deep sea and everything in it would not have the faintest idea that anything had happened at all. Rest a moment there, and let that be reassuring, because it is meant to be. The thing that keeps you from freezing on any given night is not that the sun is still shining somewhere. It is that the earth is warm and holds its warmth and lets it go slowly. That is true every single night of your life. The sun sets and you do not freeze because the world is a great warm reservoir of heat that a few hours of darkness cannot drain. A day without the sun is simply a longer test of the same thing, and the world passes it comfortably. Now let us talk about what would actually be affected, because there are real consequences, and they are more about light and life than about temperature. The first and most immediate is the plants. Plants live on sunlight. They use it every daylight hour to build sugars out of air and water in the process we call photosynthesis. It is the foundation of nearly the entire living world, the way that the sun's energy gets turned into food that everything else can eat. For a single day, though, this would not matter much. Plants do not photosynthesize at night anyway. Every night, all over the world, the green world stops making food and simply waits for morning. A day without the sun would be, to a plant, essentially one long night. Slightly stressful for some, perhaps, but not remotely fatal. Plants routinely survive far longer periods of darkness, through long cloudy spells and polar winters, drawing on the reserves they have stored. One dark day would do essentially nothing to them. So the food chain would hold. The plants would wait. The animals that eat them would be a little hungry and a little confused, but nothing would starve in a day. The confusion, though, would be real and widespread, and this is one of the more interesting parts of the scenario, because a great deal of life on this planet runs on a clock, and that clock is set by the sun. Almost every living thing, from the smallest bacteria to the largest animals, has an internal rhythm tuned to the daily cycle of light and dark. It governs when we sleep and wake, when flowers open and close, when animals hunt and when they rest, when birds sing. It is called the circadian rhythm, and it is astonishingly deep and universal, and it is calibrated by the light of the sun. And it is not merely a habit that could be shrugged off. It is built into the body, right down into the individual cells. You have a clock inside you, a real one made of chemistry, that keeps roughly 24-hour time all on its own, even in total darkness. It governs your temperature, which rises and falls over the day, and your alertness, and the release of the hormones that make you sleepy at night and wakeful in the morning. Nearly every creature has one. Even plants have them, opening and closing on schedule even when kept in constant light. Even simple single-celled organisms keep the beat. But these internal clocks are not perfectly accurate on their own. They drift, running a little fast or a little slow, and they need to be reset each day to stay in step with the real world. And the thing that resets them, for almost everything alive, is the light of the sun. Every morning the light comes, and every internal clock on the day side of the earth is nudged back into agreement with the turning of the planet. So a sudden day without a sun would throw all of that into confusion. When darkness fell at noon, birds would fall silent and go to roost, thinking night had come, exactly as they do during a total eclipse. Flowers that close at night would begin to close. Nocturnal animals would stir and come out. The whole living world would begin, gently, to prepare for a night that had arrived at the wrong time. And then that night would simply go on and on past the point where dawn should have come, and the confusion would deepen. The animals waiting for a sunrise that did not arrive. The birds that should have begun the dawn chorus, silent, waiting. It would be, across the whole daytime half of the world, an eerie and prolonged holding of breath, as the living world waited for a morning that was running impossibly late. We actually know what the first part of this looks like, because we see it during total solar eclipses, when the moon briefly blocks the sun for a few minutes. In those few minutes, the temperature drops, birds go quiet, animals behave as though night is falling, and a strange hush comes over everything. People who have witnessed a total eclipse often describe that sudden hush, that response of the living world, as more moving than the sight in the sky. A day without the sun would be that same hush, extended and deepened, held for a full 24 hours. There are wonderful accounts of this, gathered over centuries of eclipse watching. Cows lying down as they do at nightfall, bees returning to their hives, chickens going to roost, flowers folding their petals, spiders in some records beginning to take down their webs as they do at dusk, and then, minutes later, when the light returned, starting to rebuild them thoroughly confused. Crickets and frogs beginning their evening chorus in the middle of the afternoon. The whole living world reading the darkness as the coming of night and beginning to do all the small things it does at nightfall, only to have day return a few minutes later and leave everything bewildered. Now take that and imagine it not for the 2 or 3 minutes of an eclipse, but held for a full day. The animals would not merely be briefly confused, they would settle into night, properly as far as their bodies were concerned, and then wait, and wait. Through the hours when dawn should have come and did not. It would be across the whole world, the longest and strangest night the living world had ever been asked to sit through, and it would sit through it, patiently, because that is what living things do in the dark. They wait for morning. Rest a moment on that image because there is something almost tender in it. The whole living world, tuned so deeply to the rhythm of the sun that it responds within minutes to its absence, waiting patiently, trustingly, for a sunrise it has never once been denied, and then, at the end of the day, being given it back. Now let us talk about the weather, because this is a real effect and it is one people rarely think of. The sun does not only light and warm the world, it drives the weather, all of it, every wind, every storm, every cloud, every current of air is ultimately powered by the sun heating the earth unevenly, warming the equator more than the poles, and the day side more than the night side, and setting the whole atmosphere churning to move that heat around. Take the sun away for a day, and the engine of the weather would begin to wind down, not stop, because the atmosphere has momentum and the oceans are still warm and driving things from below. But the daily heating that builds up afternoon storms and stirs the winds would be gone. In some places, the air would grow strangely still. In others, the sudden cooling of the land while the sea stayed warm would set up unusual winds and fogs as air rushed from the warm ocean toward the rapidly cooling land. It would be a strange day for weather, full of odd stillnesses and unexpected breezes. As the great machine of the atmosphere briefly lost the power source that drives it, but it would only be a pause. The moment the sun returned, the engine would spin back up, and within a day or two, the weather would be entirely back to normal. There is one effect worth mentioning, though, because it would be dramatic in a particular kind of place. Along the coasts, the land cools far faster than the sea, as we have said, and air tends to flow from wherever it is cooler and denser toward wherever it is warmer and lighter. So as the land chilled and the ocean stayed warm, air would begin to pour off the cooling continents and out over the warmer seas, and the warm, moist air rising over the water would form banks of cloud and fog. So the coasts in particular might see thick fog roll in and strange winds blowing seaward and an eerie stillness inland, all through the dark day. It would be weather unlike anything in the records, not violent exactly, but wrong, out of season and out of pattern, as the atmosphere tried to adjust to a world that had suddenly lost its furnace. And then, when the sun came back, all of it would fade, and the ordinary rhythms of wind and weather would reassert themselves within a day or two, as though nothing had happened. Now, let us talk about people, because in truth, the greatest danger in a single dark day would not be the cold or the plants or the weather. It would be us. The physical effects of one dark day are survivable for almost everyone, almost everywhere. But the human response to it might not be so gentle. Imagine it. At noon, with no warning anyone understood, the sun goes out. The sky fills with stars. The world goes dark and begins to cool. And nobody knows whether it is coming back. That is the truly frightening part, and it is worth being honest about. On the day itself, the people living through it would not have the comfort we have tonight of knowing that it lasts only a day. They would not know how long it would last. They would not know if it would ever end. And that uncertainty, more than any physical cold, would be the real trial of the day. There would be fear, on a scale the world has never seen, because it would be happening everywhere at once to everyone, with no refuge and no explanation. And fear on that scale can do a great deal of harm very quickly. But I want to be gentle here because this is a story for resting, not for worrying. And the deeper truth is that the physical world would be fine. The planet would ride out the dark day without difficulty. The oceans would stay warm. The deep life would not notice, the plants would wait. The animals would hold their breath, and then the sun would come back. And there is something worth saying about that fear too, which softens it. The reason it would be so frightening is precisely that it has never happened. In all of human history, across every culture and every generation, the sun has risen every single morning without fail. That perfect, unbroken reliability is so total that we do not even think of it as reliability. We simply assume the sun. It is the one certainty underneath all the others. And that assumption is correct. It is not a naive hope. It is one of the best founded expectations a person can have, resting on 4.5 billion years of evidence, and on physics we understand extremely well. The sun rising tomorrow is very close to the surest thing there is. The fear in our imagined dark day would come entirely from not knowing that the physics guaranteed a sunrise, but we do know it. And so, lying here tonight, you do not have to carry that fear at all. The people in the story would not know the sun was coming back. You do, so let us go to that moment because it is the loveliest part. After 24 hours, the sun switches back on. And of course, we would not see it for 8 minutes and 20 seconds, because the light would have to cross the gap again. So there would be one final wait. 8 more minutes of darkness after the sun had already returned, the mirror image of the wait at the beginning. And then the light would arrive. For the half of the world that had been in darkness at the moment of return, the sun would rise, or rather simply appear, blazing back into a sky that had held nothing but stars for a full day. And the warmth would come with it, the first touch of it on cold ground and cold skin, and the world would begin immediately to recover. The plants would resume photosynthesis within moments, as though a held breath had been released. The birds, so long confused, would erupt into song, a dawn chorus for a dawn that had been a full day late. The animals would stir and resume their routines. The temperature would begin to climb. The weather engine would spin back up. And within a day or two, the warmth would have returned, the rhythms would have reset, and there would be almost no trace left that it had ever happened except in memory. Picture that first light arriving. For a full day, the sky has held nothing but stars. The ground is colder than it has ever been. Everything living has been waiting hour after hour through a night that would not end. And then in the east, or wherever the sun happens to lie, the black sky begins to pale, and the stars begin to fade, and the first true daylight in more than a day spills back across the world. And the warmth comes with it, not slowly. The moment sunlight touches cold ground, it begins to warm it. Cold skin feels it at once. The whole day side of the world, which has been holding its breath in the dark, would feel the sun come back on like a hand laid gently on the shoulder, and everything, all at once, would begin to be all right again. It would be, I think, the most joyful sunrise in the history of the world. Every person alive, having feared that the sun might never return, watching it come back. There has never been a dawn that anyone was grateful for in quite that way, because there has never been a dawn that was ever in doubt. That one would be. The oceans, having lost so little, would warm the thin layer at their surface back to normal within days. The deep sea would have nothing to recover from. The soil would warm. The ice that had formed in the coldest places overnight would melt, and the world would simply go on. Rest a moment on that, because it is the heart of tonight. The earth is resilient in a way that is easy to forget. It is a great, warm, stable thing, wrapped in air and ocean, and a single day of darkness is, to something that size and that old, barely an interruption. It would take it in its stride. It has weathered far worse. It would lose one day's warmth from its surface and take it back the moment the sun returned, and carry on as though nothing had happened. Now let me tell you why none of this can actually happen, because that part is important and it is reassuring. The sun cannot go out for a day. It cannot flicker or pause or switch off and on. It simply does not work that way, and understanding why is one of the more comforting facts in all of science. The sun shines because of what is happening deep in its core, where the pressure and temperature are so enormous that hydrogen is being fused into helium, releasing energy. And that process is not a flame that could be blown out. It is a vast, stable, self-regulating balance that has been running steadily for 4.5 billion years. And that phrase, self-regulating, is the key to why it is so steady, and it is rather beautiful. The sun is held in a perfect balance between two forces. Its own enormous gravity is forever trying to crush it inward, and the heat of the fusion in its core is forever pushing outward. The two are exactly matched, and they hold each other in check, and the remarkable thing is that they correct each other automatically. If the core were to burn a little too fast, the extra heat would make it expand slightly, and expanding would cool it, and cooling would slow the burning back down. And if it burned a little too slow, it would contract slightly, and contracting would heat it, and heating would speed the burning back up. The sun is its own thermostat. It cannot flare up or gutter out, because any change is immediately damped by the balance itself. That is why it has been so astonishingly steady for so astonishingly long. It is not a fire that someone tends. It is a self-correcting equilibrium, one of the most stable arrangements in the entire universe. And here is the beautiful part. The energy produced in the sun's core does not reach the surface quickly. It takes an extraordinarily long time. The light and heat generated in the center have to work their way out through the immense thickness of the sun above, being absorbed and re-emitted over and over, and that journey takes not seconds, not years, but many thousands of years. Let me try to give you a sense of why it takes so long, because it is one of the stranger facts about the sun. You might think that light produced in the core would simply shoot out to the surface at the speed of light, which would take a couple of seconds since the sun is not that wide compared to the distances light usually crosses. But the inside of the sun is not empty. It is packed unimaginably densely with matter. And a ray of light produced in the core travels only the tiniest distance before it slams into a particle, is absorbed, and is then spat back out again in some random direction. And then it goes another tiny distance, and the same thing happens. And again, billions upon billions of times. So the light does not travel outward in a straight line. It staggers, like someone lost in an enormous crowd, taking a step and being knocked sideways, taking another and being knocked back, making almost no progress in any particular direction for a very, very long time. It is sometimes estimated that a single packet of energy can take tens of thousands of years, or even longer, to work its way from the core of the sun to its surface, bouncing the whole way. And then, once it finally escapes the surface, it crosses the entire distance to the Earth in 8 minutes. Think about that contrast. Tens of thousands of years to fight its way out of the sun, and then 8 minutes to cross the vast gulf of space to your window. The hardest part of a sunbeam's journey, by far, is getting out of the sun, which means that the sunlight falling on your window today was made in the sun's core a very long time ago, and has only just now finished its slow climb to the surface and its 8-minute flight across space. And it means something wonderfully reassuring. Even if, by some impossible means, the sun's core stopped producing energy this very instant, the surface would not go dark for thousands of years. There is that much energy already in transit, already stored in the body of the sun, working its way outward. The sun is not a light that could be switched off. It is a vast, slow, glowing reservoir, and even a total shutdown of its engine would not dim it for longer than human civilization has existed. So the sun cannot go out for a day. It cannot go out for a year. It could not go dark in any sudden way at all, no matter what happened, because of that enormous stored warmth and that slow, patient, thousand-year journey of light from its core to its surface. The sun is one of the steadiest things in the entire universe. It has shone with barely a flicker for 4.5 billion years through the whole history of life on Earth, through every night that every creature has ever slept through, and it will go on shining steadily for billions of years more. So let us come back now, gently, and put the whole thing down. The sun is exactly where it has always been, doing exactly what it has always done. It is not going to flicker. It is not going to pause. It is the most reliable thing you have ever known, more reliable than anything human, more reliable than the ground, which shifts, or the sea, which moves. It simply shines and shines and shines, and it has never once failed to return in the morning, not in 4.5 billion years. And the deeper comfort of tonight is not even that the sun is steady, though it is. It is that the Earth itself is steady, that it is a great, warm, patient thing that holds its heat, that could weather a day of darkness without difficulty, that keeps you from freezing every single night, not through any effort, but simply by being large and warm and slow. You are held by something enormous and stable and kind, in that sense, every night of your life, and it asks nothing of you and it never lets go. So let your breathing slow and let the black noon sky and the silent waiting birds and the long cold night that ends all drift away into the realm of things that make interesting stories and never actually happen, and keep, if you like, just the one comforting picture from all of it. Not the darkness, which will not come, but the warmth underneath everything. The ocean, holding its heat so patiently that a whole day without the sun would barely touch it. The ground beneath you, still warm from 1 billion days of sunshine. The sun itself, so steady that its light takes tens of thousands of years merely to climb out of its own core. A reservoir so deep it could not go dark suddenly if it tried. You are surrounded on every side by enormous, slow, patient warmth, and it is not going anywhere. You are on a warm world, lit by a steady star, and both of them will still be exactly as they are when you wake. The sun set this evening, as it always does, and it is making its ordinary way around to your side of the world, and it will be there in the morning on time, unremarkable and faithful and warm, as it has every single morning of your life and every morning long before you were born. Sleep now. The sun is coming back in a few hours, exactly as it always does. There is no dark day coming, no flicker, no pause, nothing to watch for.